Hello everyone, thank you very much for inviting me. As you see, I am a mathematician. I'm not an epidemiologist, but I'm here to explain you what we did recently in mathematics using LLMs and how it will, for some of us, we think that it will change a lot the way we do even mathematical research. Don't be afraid by the number of slides. So there are many screenshots. Usually I say to my PhD students, the rule is one slide for 2 minutes. So it does not mean that I will speak 79 times 2 minutes. Don't be worried about this. Okay, so first maybe I present myself, just so to explain why I'm here today and how I'm a specialist of mathematics in particular, and in general, and AI in particular. So yes, I am a professor of mathematics at the University of Luxembourg. I do research in mathematics and also in AI recently. I'm the director of the bachelor in mathematics, and it echoes what François just said about the way we train the next generation, and we have a lot of discussions with colleagues to understand or to think on how to change the way we teach our students in this era of AI. I also co-founded a startup 3 years ago after the release of ChatGPT to the public, because we thought that it was a good time also to train private and public companies to these objects so that they know what it is about, what are the risks, what you can do with it, and so on. And generally, I'm curious about everything related to AI and its implications. So here you see a book I wrote recently about an immersion in the heart of AI. Okay, so this is a plan. So again, so it looks a lot, but I mean, the first 4 points, I just would like to give you the context. So maybe you are not mathematicians, so most of you. And so I would like just to explain very briefly what is mathematical research, so that you know on what I'm talking about, how we train mathematicians, why mathematicians are useful, I hope so, and how computers have been used in mathematical research so far. And then we will start discussing where we are now and what is happening given the emergence of AI. And then I am here mostly to tell you about an experiment I did called the Malevin-Stein experiment, where instead of just saying, okay, I give an LLM a problem and it managed to do it, I just wanted to document everything and to show you exactly what we did, what worked well, what worked less well, and so on. And then to think about what is the future for mathematics, and maybe it echoes also the future of all research in general in this age of AI. Okay, so what is mathematics research about? So no, mathematicians don't just solve equations. What we do daily is more that we explore vast landscapes of ideas, and how and why. So basically, I would say that we have 2 sources of problems. We have big challenges, like some of them are quite known, Riemann hypothesis, things like this. And it does not mean that all mathematicians are trying to solve these big challenges. They are like Olympic Games, so only a few of us would be able one day to make some progress on these big challenges. But there are also like satellites, smaller challenges, but essential problems around them. And we develop some tools, and then in the end, it makes this topic grow and grow, and then new ideas and so on. And this structures mathematicians into communities. For instance, I would say I am in 4 communities. One is Stein's method, so it's a keyword you will see in the next slides. Malevin calculus, and more broadly stochastic analysis, and even more broadly probability theory. And the way we share our research is mainly by writing papers, and they appear on arXiv, or they are published on journals. And we also attend conferences, and these conferences allow us to identify open questions, research gaps, and feed our research. So this is one way of doing research. So I mean, just to enter a community and try to extend the state of the art and so on. But also, and maybe it's more related to this audience today, we have many problems coming from other sciences, like it's coming from physics, biology, economics, computer science, epidemiology, and so on. And these fields often inspire new mathematical theories. So sometimes we can recycle something which is already existing, but sometimes a new problem emerges and we try to solve it. Okay, so it was very quick, but now let's make let's think on how mathematicians are trained. In mathematics, training is a long and demanding journey, maybe as any other research field. But the point is that we have basically 3 steps in our training. The first is that when we are students, so in mathematical studies, what we do is we learn the students to get abstract reasoning and the art of writing rigorous proofs. So this is why we are known in mathematics to be very rigorous. Each step must be clearly proved, and okay, so we learn the students how to write such proofs. And then, if for such students who want to become mathematicians, they have to do a PhD. And here, the idea is more to learn through practice, right? So what you do in general for a PhD student, you give him or her some work to read first, and then try to extract a nice question that you can solve. And then the PhD student will try an idea, will fail, will try it again, and this under the supervision of a senior researcher, so the PhD director. And then, as researchers, we continue to advance our research through discussion in general. So we have some seminars, we participate to conferences, we have informal conversations. And it always happens that you have a good question at some point during the coffee break, and this is the start of a new direction. So I would say that in short, mathematicians are shaped through years of trial, error, and intuition building, which are the main 3 steps in order to train mathematicians. Okay, why do we need mathematicians? Because in this era of AI, we could maybe think that we are no longer useful, but mathematics is everywhere. So in engineering, finance, medicine, digital technologies. And what we do basically is that we provide models, we provide tools, and we provide methods that enable scientific and industrial progress. And many of us also teach, which is also an important part of our job, because it helps new generations to develop their critical thinking. And so I would say that mathematics is a quiet but essential pillar of modern science. So it's difficult for us to explain what we do to a general audience, because in general, people are lost if you try explaining what you do. You cannot show them nice pictures and so on. But if you think about it, it's a language of science. And so I think for this, we cannot make mathematicians disappear. And my last slide about the state of the art, let's say, it's not new that mathematicians use computers for their research. So here we are thinking, I will develop what we do recently about create new mathematics. So this is very new. But before that, we use computers and softwares a lot. For instance, here I have a screenshot of a Wikipedia web page about Maple, where we can use such systems just to help us to make a long development, and we are sure that there is no error, which is not the same for when we use LLM. So in all these things, we are 100% sure that it is correct. We can do also a brute force search when you have many things to explore, many different situations. You can ask the computer to do it. For instance, in number theory, you would like to test something. you manage to prove that it's true starting from n is 1 million. So you can ask the computer to check that it's true again until 1 million. We can do formal proof verification using, for instance, lean. And also, and it's very important, when I started my PhD, it was the very beginning of internet, the email, and so on, and it changed also a lot the way we can share and we can discuss with other mathematicians. Nowadays, it has become not the rule, but not an exception to work with someone in the US you never met before, and just because you exchange by emails and so on. And also you have access to Wikipedia, which is also in mathematics very well done. You have some forums like Math Overflow, when you can ask questions to people, and there are some who can respond to you and so on. So it changed also the way we do mathematics using email, Google, Wikipedia, and so on. Okay. But I'm here more to speak about this paper I released in beginning of September this year. So it's about an experiment using GPT-5, which is the last version of GPT. So now it's GPT 5.1, but the change has not been very big. We are speaking about ChatGPT 5.2, which should be released in a few days. Just to counterattack Gemini Pro, who is now considered to be better than GPT. But I would like to explain you this experiment, just not saying, okay, we did this and we obtained this as an output and we are very happy, but to explain exactly all the steps we followed. Okay, but before telling you this, I would like just to show you that, I mean, this is, so the paper I'm going to discuss, my paper I'm going to discuss, but there is also a similar experiments that have been posted mainly on social media. So for instance, you have this researcher, Pata Ivanisvili, who claims that GPT-5 Pro was able to find a counterexample to a conjecture which was open which have been open for 10 years. But when you see something like this, if you are not a specialist, it's difficult for you to know whether it's something which was open just because nobody really tried to solve the problem, or it was really a big problem, and this it's difficult for the general audience to figure out what it is. There is also many activities, for instance, here in Paris, at the Collège de France. So you see that it was 1 month ago. So there have been a workshop where people are trying to explain what they think, what they do on the use on AI for doing mathematics. So here it's Timothy Gowers. He's a Fields medalist. So he plays at the Champions League of mathematics, I could say. There is another one, even more famous, Terence Tao, who is considered as the Mozart of mathematics. So for some people, this is the most, the smarter human being on Earth. Because he is really in mathematics, he's really at the top, and he's starting to do also to use AI to do mathematics and explaining what he does and so on. So there is some activities. October, more recently November, so last month, there have been this paper on the archive, mathematical exploration and discovery at scale, still with the same Terry Tao. And so among this team of 4 persons, there are 2 mathematicians, so Terry Tao and another one, and 2 people from Google DeepMind. So they are combining their force to make mathematical discovery at scale. And so we can think that this is the beginning of something. So is this year a turning point for us? We are many to think that it's the case, including myself. In 2015-17, we had this AlphaGo system, which was able to beat the world champions in the play of Go, which is a very complex game. Then AlphaFold have been mentioned already. which gave rise to the Nobel Prize in chemistry. Then we had alpha proof last year, and it was the first time that such a system was trained and able to get a silver medal at the Mathematics Olympiad. So Mathematics Olympiad is something we could say at the boundary between studies and research. So this is for the top students, but it's not research in the sense that we have the solution to the problems. And it was believed many years ago, some years ago, I would say, like in 2020, that it would be impossible using LLMs to obtain a medal at the Olympiads because it was considered as very difficult. And especially if you compare with what was the situation in 2022 when GPT 3.5 was released to the public audience. So this is the date where it was released. There were people trying to play with it, like are chicken eggs bigger than cow eggs? And then the LLM starts responding something, of course, which has no sense. And we were here in 2022, and 2 years later, we had the same system able to win a silver medal. Okay, silver medal was seen like a very important achievement, and at that time, okay, so this is the best we can hope, certainly. And 1 year later, we got the gold medal with this Alpha Evolve. So each time you have Alpha, it means that something developed by Google. And also OpenAI also was able, so we have two systems able to win a gold medal at the Olympiads. And so we are here, exactly. And here, this is a program which will be launched by Google next year, 2026, where they have a program called AI for Math. And we can, if we see this progression, so from the cow eggs to a gold medal at Olympiads, and then we can expect that we will have something which will change dramatically the way we do research in mathematics. Okay, but let's start from the start. Just to know, I come back to my paper. It was in August, so you see that already from August from September, sorry, to today, there have been already many activities, but it's like this in AI. So each week, each day, even you have new technologies which are better than the previous one, and so on. So we don't know when it will stop, but it started. So my experiment started from this a post on X, so Twitter, by Sébastien Bubec, which was this following. So claim GPT-5 Pro can prove new interesting mathematics. Proof, I took a convex optimization paper with a clean open problem in it and asked GPT-5 Pro to work on it. It proved a better bound than what in the paper, and I checked the proof it's correct. Okay. So when you say something like this, if you are not a mathematician, you can say, okay, it's great, but I have no idea who is this guy, and can I trust him, and so on. I am a mathematician, so I can read the output and this one. But even more important, I know Sébastien Bubec because we are more or less the same generation. And before, so let me tell you who is this guy. So he's someone working at OpenAI, so developing the mathematical capabilities of ChatGPT, let's say. But before that, he was at Microsoft, and even before that, he did a PhD in mathematics, in statistics. He's a former student of the École Normale Supérieure de Cachan. Then he did a PhD in Lille. Then he had a position, he was a statistician at Princeton University. And then he decided to leave academia to go to Microsoft and OpenAI. So when he said this, I'm a mathematician, I know that he knows what he's speaking about, but also he's working for OpenAI. So if you say GPT-5 Pro is doing this and this, you don't know if it is doing this, if saying this because this is true or because he wants people to think that it's. So what I did, we spoke about reproducibility. I take my ChatGPT and I wrote exactly the same prompt and try to figure out what we get. The point is that he has, of course, GPT-5 Pro, which is $200 a month. I have GPT-5 Plus, just $20 a month. So the difference is big, of course, and the difference in mathematics is that the reasoning. So here you see the reasoning was 17 minutes. So after 17 minutes, he produced something. When I do such an experiment, it is like 3, 4, 5 minutes. So it is reasoning less. So I can imagine that for the plus version I have, at some point the system say, okay, no, stop, it has been too long, produce the answer you have and see what you get. So I tried to reproduce and it did not work for two reasons. First, because you know that this is a notion of temperature in LLMs. The same prompt does not give the same answer. This is built for this, to get a variety of responses. Second, I have not GPT-5 Pro, but GPT-5 Plus. And even more importantly, this made a buzz. And so there are many people speaking about this thing. And so maybe GPT is able to go to internet and to figure out, and so to reproduce, to mimic again this. Okay, so there have been many buzz around this thing, and one something more nuanced was this comment by Ernst Ryu, who is an assistant professor at University of California, UCLA, who says that, okay, this is really exciting, impressive, but this stuff is in my area of mathematics research, convex optimization, and I have a nuanced take. And the nuanced take is that basically, he claims that he could prove exactly, so the thing is new, but he could prove it in a few hours just because, I mean, it's not something like was very impressive concerning the ideas used. It's more technical. Okay, so you see such comments, and then I ask myself, okay, I don't want to make the same things, and first, so I would like to make such an experiment, but in my area of research, so that I can really say if it is really good or not. And second, I don't just want to give you the prompt and the output and hiding all the conversation, because you never know if it has been obtained by luck, or if it is something that is more a rule than an exception, or if you tried many different things and in the end you just keep one thing, and so on. So I asked my PhD student and my postdoc just to make this experiment with me, and the idea was we wanted to document everything, to explain all what we did. I have just 2 slides about mathematics. I'm not going to read it, don't worry, but just to explain just what we did so that I can show you better. So this is a theorem in mathematics. And what this theorem says, and what you have to understand for what I'm going to say in the next slide, is this is a qualitative statement stating that under some assumption, you have a sequence of random variables, so quantities that behaves randomly, which converges to the Gaussian distribution. So you know that when n is big, so n is my parameter, you know when n is big, the law of my random variable is being closer and closer to the Gaussian distribution. It's qualitative because it just means that you know that some sequence go closer and closer to something else, right? But you have no idea on the rate of convergence. So what does it mean n is big? So we have another quantitative version, which is a result I proved with some colleagues almost 20 years ago, where not only we say that we know that something is close to another thing, but we are also able to give a rate of convergence. And here, if you know just a bit about probability, so here in this statement, you have a random variable capital F, and here we are saying that any probability that we can compute on this random variable f can be replaced by the same thing where n01 means a standard Gaussian. And then we look at the error we do. We take the biggest error, the supremum, and we are able to bound it by something, basically. So we have an idea on the rate of convergence. Okay, so that's all for the mathematical thing. When we invented this, so this is something I know very by heart because I am the father of the theory, let's say, and I make it evolve with many colleagues and many people during the last 20 years. So I know exactly where are the traps, I know exactly what we can do, what we cannot do, and so on. And at that time, I felt that it is something important, and I wanted to keep track of all the papers which, in some sense, are using this theorem, because it's very versatile. even if it does not look very versatile. And I started to have a web page referencing all papers related to what is nowadays called the Marie-Einstein method. And so each year I just take all papers which at some point use this thing. And it was excellent for my experiment, because now if I wanted to test capabilities of ChatGPT, I can just take one of these papers and try to extend something inside to another setting. And I find reference 7. So reference 7 is a paper by Bass, O'Connor, and co-authors about force moment theorem for sum of multiple integrals. And it is very interesting for me because it's a qualitative statement. So I have here a qualitative statement, and I can ask ChatGPT to transform it into a quantitative statement, so associating a rate of convergence using the Marie-Einstein method. Okay, so this is what we did. Here is this paper, so it's just to show you that, okay, so this is a paper with mathematical proof. Just for those who are mathematicians or former mathematicians, there is nothing related to rates of convergence. It's about tightness and so on. Okay. And now let me start the experiment. And here is a prompt I gave to ChatGPT. So I explained that this paper, the first one, I'm not going to read the archive code, establishes a qualitative force moment theorem for the sum of two Wiener integrals of order P and Q. So I'm just describing what this paper does. And then building on the Marie-Einstein's method. So I gave another reference for what it is. I wrote a book on it, but I did not want to put the book because even if it is my book, I'm not supposed to have the electronic version. That I took from LibGen. But there are some lecture notes I wrote for a course in Collège de France 10 or 15 years ago, so which consists more or less the state of the art about what is needed to pass from the qualitative to quantitative version. I must admit that I know exactly how to, before doing with ChatGPT, if you ask me to do it, I would make the same answers that Ernst Rioux. It would take me a few hours to make it myself, right? So I know exactly how to do it. So it's not that I am trying to use ChatGPT to discover a thing, but more to checking what it is doing. And so building on this, so could you derive a quantitative version for the total variation distance, so meaning a rate of convergence, with a convergence rate depending solely on the force cumulant of this sum? So this is my minimal prompt, so 6 lines, 2 papers. So I give the paper, I give the ID basically, and then I ask it to combine the two. Okay, so there were reflections during 3 minutes, because I have the plus version. And first answer, yes. And then it started to give me a sketch of the proof. So step 1, you do like this. Step 2, you decompose Step 3, you control each term. So, okay, I'm not going to let you read because you are not a mathematician, but you put everything together, and okay, and then that's it. You get your statement, which is this one. This statement I'm looking for. The total variation distance is bounded by the force cumulant, which is a force moment -3. So it is exactly what I asked it to do. So I was a bit impressed, but then I say, okay, you are not my supervisor. You are not going to tell me that step 1 I must do this, step 2 I must do this, and so on. So give me all the details of all the steps. Okay, so another reflection of 3 minutes. And then it started to give me all the details for each step. So first he stated the theorem in a mathematical way. Then gave me some preliminaries, ingredients and preliminaries. So all the notations which are used in the rest of the proof. And then step 1 started to, oops, it's not me. Okay, well, I continue. Step 1, it started to give me the details. Step 2, step 3, step 4, and then some remarks, call to action, as we say for LLMs in the end, and some references. So he tell me where it took all the things that appeared. Okay, and so it looks like it was done. But of course, now my job now it consists in trying to check every details. So we change the thing. So I'm a human being checking what an AI did, but still I cannot publish something I did not check myself. And then when I did this, so let me just see here. You have this double star formula. So for you, it looks very much correct, but it's indeed wrong. So we have this double star formula. So you see, this is really in this proof, and you have to be a specialist to see. This is the only mistake there is in all these 4 screenshots, this double star formula. I did not want it to say, okay, the formula is wrong. I wanted it to discover by itself. So I said, can you check your formula for covariance y squared z squared and provide me with the details? Just to my hope that he tell me, okay, it's wrong, because then when I wrote down the detail, I remember that I did an error and so on. Okay, great question, of course. Yes, let's check it carefully. And then he started to give me a proof, which is wrong. And the wrongness of the proof is exactly here, which is very subtle because, okay, you have no idea of what I'm speaking about, but just believe me, if you remove this tilde here, this equality becomes correct, but with the tilde, it becomes wrong. Okay, so it's a tiny mistake, but which makes the whole proof completely wrong. And so, okay, no, I did not want to play too much with it, so I told you, I think you are mistaken in claiming exactly what I just showed you. What should that be the case? Of course, I am absolutely right. The identity is not true in general. I mistakenly wrote it, and then he gave me the correct identity, which now is correct. I'm not sure he found it by itself, because it was in the second paper I gave it in my original prompt. So this identity was written there. Okay, and then I say, okay, so in the end, how do you prove the inequality? Because now you have the correct equality. We come back to step 3, and so he made the thing, and so. And so now it was correct. Okay, and then I say, okay, turn our discussion into a research paper prepared for journal submission. Follow my writing style, so 0 shot or few shot thing. So he learned from my style, so I gave it one of the paper I wrote. And I asked the paper must include introduction, main result, detailed proof, bibliography. The final output should be a LaTeX file that compiles without errors, and here it was. So I got a paper that I can submit, and okay, I did not make the last step, but I'm sure that this paper would have been published not in the best probabilistic journal, but at least an average probabilistic journal, and I would have been very proud to increase my number of publications by 1. But it was not exactly the last thing I did, so I asked also if he can ask a concluding remarks section, exactly the kind of questions, containing exactly the kind of questions you can ask after a talk. So I give you this talk, and do you have questions? Yes, can you extend this to the Poisson case? This is the kind of things you could ask me. And so it was exactly what was written in this thing. And I say, okay, maybe it's good idea. So I open a new thread, and again, I give a paper. So it was his idea, so its idea. He gave it a paper, so the same first paper, and then I asked, I would like to extend this to the Poisson case. So what we did was the Gaussian case. We have Gaussian and Poisson, so you don't have to know what exactly it is. But then I give you the second paper is all it has to know about the Poisson case and extension to the Poisson case. So he gave me a result. And here it was, so in the Poisson case, basically you have to add more assumptions, assumptions A. So you have to ask the first condition, the first quantity that goes to 0 and so on, and these conditions were not in the Gaussian case. So here it was correct completely, but the things that were not completely satisfactory for me is that he added assumptions which was unnecessary. Turns out that the last assumption that is required to the theorem to work is actually automatically satisfied. So we don't have to ask it. So it's like you know, in mathematics we say that when the problem is too hard, what you can do is to take part of the solution into the assumptions. Okay, and so in the end, you manage to prove what you want, but most of the conclusion is the assumption. And so all of the art of mathematicians is to do the converse way. So here, I just wanted to make it, to realize this. So is there, I don't want to give it the point. So is there anything that could show that this guy is always positive, and for this, from this, we can infer that it goes to 0 directly? Short answer, no. Oh, God. So this time it tell me no, but the short answer should have been yes. So he explained why this is wrong. Well, of course, it's not, this is rubbish. And so what about 2.4? So here I just say this, so he managed to find where is 2.4, in which paper I gave it, so. And then, yeah, you are right to point, it does force a sign, and then give me the correct proof. Okay, and then I asked, can you give me the new statement of the theorem? So in this new statement, he removed the assumption which was unnecessary, and it is no part of the conclusion, which is correct. But then I wanted it to check that the other assumptions are not of the same type. I cannot remove them because of the same thing. So in order to do this in mathematics, we have to find a counterexample, right? So meaning that you remove this assumption, and you prove that without this assumption, the conclusion is wrong. And I asked it to do it. And here it was correct. It produced me a counterexample. And yeah, that's it. And the counterexample was perfectly correct. And then I got the extension to the Poisson case. So my paper is even much bigger. Okay, I don't know how much time do I have, but I'm going to finish. So what was the conclusions of this experiment? And here I wrote explicitly 2 times that it was in August 2025, because things are evolving very quickly, and all things that we have in some given point in time does not mean that it will be something the same in the near future. So at that time, the experience was overall mixed. And for me, it was like working with a junior assistant at the beginning of a new project. Like, it allows you to explore many directions. So they are mainly correct. Can have some mistakes, but it can help you to find that this is the good theory to use instead of this one, and so. It can formulate hypotheses, it can search for counterexamples, and progressively you can adjust statements just by chatting and saying that for you it's correct, not correct, and so. So it's more like an assistant that's something that really helps you. So it's like you have one more people in the team, let's say. And for me, at that time, it only seemed to support incremental research, meaning that you have something which has been proven, and you want to add, you want to increment, you want to add an epsilon, as we say in mathematics. So something which is not very deep, but which is new because never written already. So producing new results that do not require genuinely new ideas, but rather the ability to combine ideas coming from different sources, which is exactly what my experiment did. But the point is that we had to very carefully verify everything produced by the AI. And here you have seen a very nice example of a situation where you have 4 pages of calculations. They are globally correct. There is a subtle mistake. But if you think, when you receive a research paper, in general, you don't check any details when you are the referee, and it's not your job. So, I mean, this is not the job of the author. But this kind of, I'm sure also that the paper would have been published with the error as well, because maybe we are 3, 4, 5 on the planet to know about this mistake, these potential mistakes. And if you read quickly, it looks correct, and okay, and you can be trapped by this. So yeah, in the last few minutes, what future for mathematics, in my view? As of today, I would say that AI can help already a lot. It can generate new ideas, so it can help you to explore directions you did not think of, or you cannot be specialist of everything in mathematics. We always say that Poincaré was the last mathematicians to have been able to know all about mathematics. No, it's too wide in order you must be specialized. It's impossible to know everything from algebraic geometry to statistics to probability to number theory and so on. So here, if you have an idea that maybe you could have some help from number theory, you just take a book on number theory, you put on, you give it to ChatGPT or another LLM, and you see what happened with this. It allows faster calculations. So this is not really AI, but I mean, it was in my slide, we already used computers to help us doing mathematics and, for instance, by doing calculations faster than us and more reliable than us. It can help with writing and formalizing because proofs can become cleaner and better structured. It's like writing a code. And so for the moment, you can see it like yeah, new person in your group, in your research group, and taking the best of both. So AI because of the power which gives you, and human because you can check everything and so on, but also you are not 100% reliable. So yeah, but at least if you combine the two, you can think that something better will be obtained from this. But there are many risks. So here I try to identify some of them. The first risk is overconfidence because, as we have seen, a little hidden mistake and everything collapses. We can expect also to have less original ideas because everyone is using the same system and doing the same thing, and so the data becomes more and more all the same, and in the end the output becomes the same as well. There is this problem of hallucinations that have been already mentioned. Even if the LLM is 99% reliable, just 1% in mathematics and in many also research fields makes the whole thing collapse. And also, we can expect a deep change in training. Because if you go back to my slide where I explained how mathematicians are trained, you remember that I have this PhD student stage, where basically what I gave to the LLM is exactly what I would have given to my PhD student starting with me. I gave a paper, I gave a paper with some methods, and I say, okay, try to use these methods to prove this paper, to prove this result, which extends, for instance, in this paper. And so what the student should do is to try first to read the thing, test, fail, try, and so on, and then learn. But now I can imagine that I gave this problem to my first students, and then the next day comes to my office and say, okay, I think I have a sketch of the proof. So looking, so step one we could do like this, step two we could do like this, and so on, which is exactly what I did with ChatGPT. And then I say, okay, but now you have to check any details. He will come the next day to my office and say, I check any details, and I have a proof, and I would say, okay, maybe here this formula is wrong, try to figure out, and all this process could be skipped just using an LLM, and so in the end, the PhD student will learn nothing, just his or her capability to use, to be a prompt engineer. So we don't want mathematicians to become prompt engineers. But also it comes with, so today we have the power, we have the data, we have the architectures, we know how to, we start to see something, but we have also a very important problem in mathematics, and I think in other sciences, which is we have a saturated publication system. And I think we have to reinvent our publication system. Yeah, well, we have too many publications, too few readers, no verification, meaning that today if you put a paper on the archive, nobody will read your paper. There is no, so finally, if it is wrong or correct, we don't care because nobody is reading papers. And with experiments like I did, you can expect that in a few years, the production of such papers will be even higher. As we have seen, for instance, the memoirs or the theses of our students have increased. The level of grammar, for instance, is not perfect. It does not exist nowadays, students that give you a memoir written with mistakes, grammatical mistakes, things like this, because, of course, they put on the LLM and they ask to correct and so on. So it will make an exponential growth in output, and the technology which is behind verification, like Lean I mentioned, is stagnating. So there are different scales, and so this is the main problem we have. And so I think we have to shift from publish more to publish better. But it's, yeah, I could speak about 30 minutes about it. Let me just show this last slide. So progress in AI is accelerating. If you think it took only a few years to go from co-eggs to gold medals, and now we have top researchers, top models who are joining. So we think that it will change the way the mathematical research is done significantly. Mathematicians will become architects, pilots, coordinators, but maybe lose the technical skills. And the main risk is that certainly we lose fundamental skills, like with GPS, we are unable today to orient ourselves without these tools. Dilution of our human creativity, and more importantly, but I have no time to discuss this, we are giving our knowledge, mathematical here, but in general, to private companies. And if you think, so we are trying to make Google, OpenAI, and all these DeepSeek Chinese things and so on, be the next mathematicians, and there will be no way to compete when they will decide to stop making their tool free or close to free. And we may face an unequal access to AI tools. And yeah, I connect with me on LinkedIn if you want to continue to learn about this. And thank you very much.
Only for a few questions.
So a practical question, how do you intend to train your PhD student? Because I mean, my strategy is kind of close to yours, give a problem so that they can grind their teeth.
I think the same question also arises for training the students, even not the PhD students. We have to think again on how we do. And so I think, so first we have to make them learn what is AI. So in the sense that if you have PhD students who are using the old way and compete with people using AI, at some point there will be a gap between the two. So we must train them on AI, on the state of the art, on what is possible, impossible, and so on. And then for the moment, I don't have I don't know exactly what to tell you, because for the moment we are discovering all these possibilities. For the moment, it's not at the point of being a good PhD stage. But if you give me, like, I'm always saying this, if you give me a weekend, I just work intensively on this, I think I can write a PhD studies of a good level after 2 days. But I have the expertise. So, I mean, what is important is that we manage to keep the expertise of these PhD students, and we have to invent a way to do it or to change what is important. So today, when you want to hire a new colleague, what you do is to look at the CV, and in general, what you do is the first reflex is to look at the number of publications. I think we should change this because we have to start from the end of the process to change the way we attract and we hire our students, and then mechanically it will change the way they are trained. But if you start changing the way they are trained, and if the market does not follow, so I mean we have to take the other way on. Yeah.
Thanks.
Okay, Grégoire, this is more a remark than a question, but what's very interesting talk, by the way. We are here about public health sciences and so observational sciences, life sciences. So the difference between our domain may be that you can maybe check the results of what ChatGPT is giving you as an answer. If you have the resources to do so, and you have to train and have people to do this kind of checks, while in the real life sciences or observational, we not necessarily have the possibility to check it, because it's not only logical reasoning, it's about what's the reality and how can we check in this kind of situation what an LLM or AI would give us as a result, like like this kind of result, like we have the association between X and Y and in real life, but how can we check it in this context?
Yeah, So indeed, so I mean, it's quite different because for mathematics, as you said, we can check everything. And so in the end, at least we have a way to be sure that what is produced is correct or not. In more applied science, yes, there will be people trying to not believe on what is written, and also because some scientists may misuse these tools to produce more, but something which is even wrong or not checked and so on. So we have to think collectively, but I think the answer is not to, for the moment, to ask some people what we have to do and so on, but collectively we have to be aware of this thing. And believe me, in mathematics, most of my colleagues have no idea of the capabilities, and each time I gave this talk in front of mathematicians, they discover like, wow, we can do this. So of course, some of them know, but most of them have no idea. It's like teachers. Against students. So students are using LLMs to do their homework and so on. They have no idea of what they are doing. They did not always realize that they are actually skipping their training, and so it's bad for them. But also the teachers, they have no idea. Sometimes they give some homeworks. I see the teacher of my daughter, so she gives them homeworks. So come on, nowadays you cannot give such an homework because it takes 30 seconds to be done very nicely on LLMs. But for sure, the teacher have no idea about it. So I think we must train also senior researchers just so that they can discover what is happening and then try to think on how to make this good for junior researchers. But it will take time, of course. Yeah.
Thank you.
Thank you. And just before you leave, if you not disagree, I would like to take a picture for my LinkedIn account. So if you don't want to appear, just put your. Thank you very much. Because it's not that always that I have such a rule. Thank you very much.